We are observing an anterior temporal lobectomy. The patient is under general anesthesia, their respiration maintained by the rhythmic cycle of a ventilator. Clinical assessment confirms the subject is unresponsive, lacking both reportable awareness and the executive control associated with the waking mind. Researchers played audio from a podcast into the operating environment. In a state of deep anesthesia, the expected neural outcome is silence, or at most a basic acoustic reflex in the primary auditory cortex. However, the recordings revealed the hippocampus was parsing grammatical structures and predicting the semantic embeddings of upcoming words before they were delivered. The brain was performing high-order cognitive transformations without the presence of a conscious subject. Cognitive science often treats neural registration, semantic processing, and conscious awareness as a unified phenomenon. This new hippocampal data complicates that model. It shows that the extraction of meaning can occur even when the subject is unable to report or experience that meaning. This suggests a divergence between two states, registration and access. The underlying information can be recorded without being available to the conscious mind. General anesthesia functions as a shift in boundary conditions. It leaves the brain's semantic maps in place while modifying the mechanisms of subjective ownership. We are forced to distinguish the processing of meaning from the experience of meaning. High-level computation can proceed in the absence of awareness. The depth of this processing becomes evident in the study's auditory oddball paradigm. The test involves a sequence of standard tones interspersed with unexpected, deviant oddball tones. This chart tracks the hippocampal response. Initially, the brain focuses on encoding the identity of the repeating tone. Across 10 minutes of operational time, this basic tone encoding decreases, while the brain's ability to decode the deviant oddball pattern trends sharply upward. This indicates representational plasticity. The neural system is learning and adapting to the statistics of its environment while the subject is unconscious. This adaptation extends from simple tones to the complexities of natural language. During speech presentation, neural activity predicted the semantic category of words before they were heard. This predictive behavior is distinct from basic sensory reflexes. It requires a specific parsing of linguistic context. Cognitive adaptation and contextual prediction operate as autonomous functions. They do not require the presence of a conscious reporting self. If the hippocampus can learn and predict without awareness, how do we structure these layers of cognition? We model this as a 4-tier stack. The base, neural registration, responds to structured input. Tier 2, semantic transformation, extracts meaning. Above that, consolidation stabilizes memory. But under anesthesia, it's compromised. At the top, conscious access, subjective ownership, remains entirely inactive. The Catlowitz study confirms robust activity in the bottom tiers of registration and transformation, even as the top layer of access remains dormant. The capacity to map meaning operates independently from the capacity to consciously experience that meaning. This separation is formalized within the TCGS-SEQUENTION framework. We start with registered semantic content, denoted as RSEM. This data stream enters an operational node labeled K, the consciousness filter. In a standard state, it binds and regularizes the data, outputting ASEM, accessible conscious experience. Normal waking conditions allow this filter to successfully translate registered meaning into owned experience. The administration of anesthesia alters this operational relationship. The operator node shifts to KA. While the input stream of meaning remains strong, the resulting output becomes unstable and fails to form a coherent experience. The chemical agent modifies the boundary conditions of the system, causing the filtering process to fail. Crucially, the RSEM data, the semantic input, persists. The brain continues to process the grammar and statistics of the podcast. This creates a distinct neurobiological shadow. The brain maintains a highly structured semantic map that the subject cannot access. Anesthesia decouples the semantic map from conscious ownership, leaving the underlying computational structure intact. We must be precise about the limits of this evidence. The data shows that cross-sessing occurs, but it does not suggest the patients were aware of the stimuli or possessed full comprehension. These findings suggest that global workspace theories must account for sophisticated local processing that persists without the need for global broadcasting. Similarly, while predictive signaling is clearly present in the data, it is not a sufficient marker for conscious experience. Complex computation and prediction can no longer be used as definitive proof of consciousness in a neural system. This leads us to a new paradigm: filter-decoupled neural cartography. This new cartography maps the transmission of structured meaning across an entire brain that lacks a master-observer node. Under these conditions, the hippocampus functions as a semantic projection interface, parsing data without the requirement of awareness. The neural registration of reality continues because the hardware is built to parse meaning regardless of the status of the consciousness filter. Meaning remains neurally structured while conscious ownership is suspended. The map of the world is drawn in the shadow, even as the filter fails to expose it.